In this video, I'm going to talk about the Python programming language. This is really a crash course in Python intended for those of you who have some experience programming, but maybe not experience in Python specifically, or perhaps you have a little experience in Python, but you just want a quick refresher. So in this tutorial, I'm going to be talking about how to run Python code on your computer, basic variable types, lists, dictionaries, flow control, and defining functions. So just kind of like a really, really broad overview that will hopefully help you follow the rest of the videos in this series, which are about web scraping. So first things first, Python is both a programming language, like a syntax, as well as a program that you install on your computer that allows you to execute that Python code and to get some kind of output. So Python is like, a program that you run on your computer that interprets Python code, and it's also like the code itself. So the very first thing that we need to make sure that we do is that we have Python installed properly on our system. I'm going to open up the terminal, make it a little bit bigger. If we're on a Mac, we can install Python with brew install Python 3. This assumes you have Homebrew already installed. If you don't, go to brew.sh, install Homebrew, and then once you have finished doing that, install Python using brew install Python 3. You hit enter. I'm not going to do it. It installs Python. The next thing, and I think this is really can be very confusing for people who are just coming to Python, is that if I type Python 3 and hit enter, what happens is that I'm taken to an interactive Python environment where I can run lines of Python code one at a time. So if I type 1 plus 1, 1 plus 1 here and hit enter, that executes that line as Python and gives me the output. Typically, this is not how we're going to be running our Python code, but it's really important to know that this is what happens if you just type Python, so that you know also that this is not what you're supposed to be doing. This is not the regular shell, and that you need to exit out of it. This is also actually a good way of kind of like messing around with Python one-liners, but we're really not going to be doing it in this tutorial. So to exit this, there's two ways. I can type Control and then D, that exits, or Control D exits, or I can, sort of hilariously, I can type the word exit with an open and close parentheses. If I type exit like that, it'll tell me how to exit. So I'll type exit, open, close parentheses. Okay, so let's make our first Python file. In order to do this, we need some kind of code editor. I'm assuming that most people have a code editor already on their system. If you don't, there's lots of options, but I probably, and there's no really right or wrong answer to what code editor you use. If you don't know which one to use, I recommend using Visual Studio Code. Again, you can use whatever you prefer. This is the one that I'm going to be using in this series of tutorials, though. Okay, so open up Visual Studio Code, and let's make a new Python file. I'm going to hit Command-N to make a new file, and I'm just going to type print, and then in quotes, hello. And I'm going to Command-S for save this. And I'm going to save it on my desktop as hello.py. Py tells Python, or tells our system that this is a Python file. So now we need to run this file in Python. I'm going to go back to the terminal, and I'm going to cd into my desktop, which is where this file is located, cd desktop. I'll type ls, and I'll see that there is a hello.py file here, and I type python 3 hello.py. And so again, if I just type Python, it would bring me into that interactive shell. If I want to run a Python file as code, I have to type Python3 and then the name of the file that I want to run. So if I type hello.py, we can see that the print command prints whatever we put inside of the parentheses to the terminal. Before we get into anything else, I just want to really quickly talk about comments. If you want to write some comments in your code, use the hashtag. This is a comment. You can also do multi-line comments with 3 quotation marks. 3 quotation marks makes this is a multi-line comment. And then close those 3 quotation marks. So this is a comment, it won't get executed, and so is this. If I save this and I run it again in the terminal, I will see that it's just still printing out hello. Also, by the way, with these multi-line comments, I can use a single quote, or I can use 3 single quotes or 3 double quotes. Both of them will work as long as they are the same on both sides. Okay, so let's talk about declaring variables. One notable difference between Python and other programming languages is that you don't need to say that you're declaring a variable. You just create a name, equals, and then some value. So I could say some number equals 1969. Hit save, and we've just created a variable called some number whose value is 1969. Then I can go ahead and say print some number, and we'll see that this prints to the terminal. Python does have the concept of variable types, but you don't declare those types. So some number in this case is an integer. I could also declare a floating point number. I could say sort of pi equals 3.1415. I can't remember. Right? That's a float. I can make a string with quotation marks. I could say a specter is haunting Europe, right? So a string is just you put stuff in quotes. And then a few others. A Boolean, again, this is sort of different for most things. Some Boolean equals either true or false, but you use a capital T or a capital F for Booleans. So this is integers, floating point numbers, strings, Booleans, and then the 2 other kinds of variables, which we'll come back to later, I'll talk about them later, are dictionaries and lists. So let's talk about like one of the really big differences between Python and other programming languages, which is whitespace significance. So in Python, whitespace matters, and it's how you define blocks of code. So for example, let's look at if statements. Let's say, let's make a value called specter, and we'll set it to be equal to be true. And then we'll say if, actually let's call it a specter, if a specter, and then what I write is a colon, and then I hit enter, and we'll notice that our text editor automatically indented our code for us. And then I'll write print a specter is haunting Europe. So as you likely know, in probably the programming languages that you're used to, if you wanted to define an if statement, you would use a first of all, you might put the statement itself inside of parentheses. In Python, you do not need to do that. You might also start the block of code that would be executed if the if statement is true inside of perhaps like a squiggly bracket. Again, in Python, you don't do that. You say if some value that evaluates to true or false, colon, and then everything afterwards that's indented becomes the block of code that's executed if this statement evaluates to true. So if I run this in the command line, because I set a specter to be equal to true, it prints out a specter is haunting Europe. I can also add an else by de-indenting and then writing else colon print specter is not haunting Europe. And hit save and run it. So we still get a specter is haunting Europe, but I could change this to be false. And now we'll see that it's going to print out a specter is not haunting Europe. And of course, you can put as many lines of code as you want to within these block statements. So if I could print out try again later here, and it would print both of these lines of code. So again, this is such an important concept. Whitespace really, really matters in Python. If I de-indent this line here, we'll actually get an error, and we'll see what happens. It says, indentation error, expected an indented block. And the reason is we put this colon in here, right? Which means that the next line is expected to be some kind of indentation. Python is expecting some kind of block of code to be executed, but it couldn't find any because we're basically having an if statement without anything to execute afterwards. So I can put that back in. And the other thing to bear in mind is if I de-indent, let's get rid of the else for a second. I'll just comment it out. If I de-indent this print here, right, this print statement now is no longer within this ifs block. So you have to indent it if you want to. I hope this is clear. It can be a bit confusing when you start. And it's one thing that some people hate about Python. I actually happen to like it because I like that the look of the code is and the structure of the code are kind of the same. But it's really just personal preference. Next, let's talk about strings. So strings are a pretty important concept. I'm going to go ahead and delete all these ifs, and I'm going to say message equals, and we'll just use the same line. A specter is haunting Europe. The first thing is I can get the length of our string using a special function in Python called len. I could say print len message, and this gives us the length of our string, which is 28 characters. I can access different elements of the string using square brackets. So I can write print message open square bracket 0. That gives us the first character of the string. 1 gives us the second character. 2, and so on. 2 gives us the third character. But I can also do, so that's probably what you're expecting. I can also do some really nice and sort of Python specific things. For example, I can get a range of characters. If I do, if I give a lower bound, let's say 0, and then I use the colon, and then an upper bound. So if I do 0 colon 5, it will give me the first 5 characters of the string. Or I could say 3 colon 8. It'll give me from the 3rd to the 8th character. I can also get the very last character of the string if I start with a negative index. So I can say -1 will give me the E of Europe. -2 will give me P, and so on. I can keep going back. And I can also use this within my range functions. So I can say, give me from 5 to -2, for example, and so on and so forth. So this can become pretty handy. There's also just like some useful string functions. For example, I could say message equals message dot replace, and then I could replace Europe with this video, and then I could print message. So replaces an element or a set of characters within a string. Message equals message dot upper makes a string uppercase. Lower makes it lowercase. Title makes it title case, and so on. I can also modify a string by appending values to it or prepending. So I could say message plus equals I'll do it dot the specter of communism, and then print message. So that appends to the end of a string. I could have also written this out as message equals message plus. And lists in Python work really similar to strings. So let's talk about lists. So first of all, a list in Python is basically the same as an array. In Python, we call arrays lists. They're essentially the same, but just bear that in mind because that also is like a bit of a point of confusion when you're starting and you're like Googling, like, how do I do something to an array Python? And what you should be Googling for is list, the word list, not array. So first off, you can create an empty list using square brackets. So I could say, for example, let's just do numbers equals open and close square bracket, an empty list. I'll just go ahead and print that out. I can append to the end of a list using the append keyword. So I could say numbers.append 10, and numbers.append 3, 4, let's say. Okay, so we've got some numbers in there. I can also define a list with some values in it initially, 5, 10, 22, 100, 300. I can mix values in here also like this. It doesn't matter. So if I print, we get a big old list like that. Just like with strings, I can get the length of a list using the special len function. So if I want the total list size, I type len and then the list. Again, this is a little bit different than other languages where you might see length being a property of the array itself. And I can access elements in the list using the same syntax that we used for strings. So I could say print numbers 0 gives us the first element, numbers 1 the second, and so on and so forth. And just like strings, -1 gives us the last one. -2 gives the second to last. And then I can get ranges also. So I could say 0:5, for example, would give us the first 5 elements of the list. Finally, and very importantly, I can iterate over all of the elements of the list. I could say for, I'll say n for number, for n in numbers, colon, and now this is a block, and I'll just say print n. So this will print out, this will store each value of our numbers list inside a temporary variable called n, and just print those guys out, one line at a time. Now, again, this is like, you'll notice that this way of iterating over a list doesn't make use of an index value, right? So like in JavaScript, I might write like for, I mean, there's different ways of iterating over arrays in JavaScript also, but you might write like for let, I equals 0, I is less than the length of numbers, I plus plus, and then you would reference individual elements of the list using that index value. we actually don't do that. Typically, you don't do that in Python. If I do need the index value for some reason, the way that you write that, and this is again like a bit of point of confusion for newcomers, is I would write instead of numbers this way, I would actually write enumerate. I would use a function called enumerate numbers, which then actually returns two values. So it returns I, n, like this. And enumerate gives us back both the index value and the element itself. And this is handy if you ever are doing something that requires you to have the index value as well as the value in Python. So to reiterate, if I want just every single element, to do something to every single element in the list, I write for some variable, let's say n, in numbers, colon, print n. If I need both the value as well as what its index is, I write for I or index, comma, n, in, and then I write enumerate the list. So those are sort of the two most frequent ways of going over lists. And one other note here is that, and I mentioned this before, but I can mix and match variable types in my list. So I could combine numbers and Booleans and strings all into the same list. Okay, so the next thing that we're going to talk about is the dictionary type. And a dictionary is a set of key value pairs. It looks really, really similar to object literals in JavaScript. So I can define an empty dictionary using open and close squiggly brackets. So for example, I could say person equals open and close squiggly bracket. And then I could set a key for, let's just print out person to kind of get going. Okay. And then I could add properties to this dictionary using square brackets again. I could say person, and then when I'm defining a property, I usually would use a quotation mark. I would say person name equals Carl, person alive, let's say, equals false, and then maybe we'd say person favorite books equals, what do you think, what were his Hegel's something, say something by Hegel, and we'll say capital, he likes those two things, and so on, right? So if I print this out, we get a dictionary object that has these different key and value pairs. So the name is Carl, alive is a Boolean, false, favorite books is a list, and you can kind of mix and match in here. So if I want to also, I can overwrite existing values. I can say person name, reset that to, let's say, Karl Marx, right? I could also, if I wanted to, instead of defining these values one at a time after I create my dictionary, I could create a dictionary with values already populated into it. So I'll delete that part. And I could say, for example, I'll just comment this out for a moment. Person equals, in quotes, name, colon, Carl. And then I would do a comma. And this probably looks familiar. Alive, colon, false, favorite books, and I'll just leave this empty for now, but you get the point. So this is kind of like the same, the same thing. If I want to just access certain elements of this dictionary, you can probably guess that I use an open square bracket, and then I give it a key, like print person name. And it's important to note, just like, again, just like JavaScript, like JSON, you can nest dictionaries within other dictionaries. So I could have, like, inside of this person, I could have like a best friend dictionary that has also like, some name, right, and so on, right? And if I wanted to access this sort of dictionary within a dictionary, I use, again, sort of square bracket within square bracket. So I could say person, best friend, name. And this would look for the best friend dictionary inside a person and then the name key inside of that best friend dictionary. I can also iterate over every element inside of a dictionary. So I could say for key in person, print key. And what this will do is when you use a for loop within a dictionary, it gives you all of the keys for that dictionary. I can also get the keys and values in one go from a dictionary by doing person, or the dictionary name, dot items, like this. And I would write for key, comma, value, like this. So this is sort of the very, very basics of the variable types that we're going to need. And then I'm just going to talk about two more concepts. One is function definitions, and the other is list comprehensions, which is a very powerful Python feature. So first of all, function definitions. To define a function, I use the def keyword, def, for like define. And then I could say the name of a function. I'll call it greetings. And then open parentheses. And for now, we'll do a function that doesn't take any arguments. Close parentheses, colon. And then inside of our function, we can say, we'll just return a value. Return hello. So if I call this function, print greetings, we should see hello. A few really valuable and a wonderful thing about Python functions. Well, first of all, I can obviously give it some properties. So I could say name in here, and then we could return hello plus name. Now, if I run this by default, we'll get an error because I put a parameter in, but I didn't actually, when I called the function, I didn't give any parameters. So we'll say hello Carl, and then okay. I can also give this, let's give an adjective too. Name and adg for adjective. Hello name plus you look plus adjective. So again, if I run this, we'll get an error because I've required an adjective, but I haven't given an adjective in the when I'm calling the function. So if I wrote in here, comma, you look beardy, then we'll get hello Carl, you look beardy. I can also give these default values. So I could say adjective equals, and then I can give it a default value. We'll just say nice. And that way, when I run this, we'll get the same thing, you look beardy, but if I delete this parameter, which is now an optional parameter, the function still executes correctly. The very last thing I want to talk about, and I'm going to mention it, it actually is like a slightly more advanced topic, but I'm just going to mention it because it comes up so frequently in Python, is what's called a list comprehension. And a list comprehension is a one-line method of manipulating list values. So if I go and I delete all this, and I make some numbers, let's say, numbers equals 1, 5, 20, 15, 33 or something. Let's say that I wanted to make a new list that had the same values of this current numbers list, but all of the values were doubled, right? There's lots of ways of doing this. I could create an empty list called doubled numbers, and I could say double numbers is empty, and then I could say for number in numbers, and I could say doubled equals number times 2, and then I could say doubled numbers dot append doubled. Okay, and then print doubled numbers. So this is an operation that does something to every single element of our numbers list, and then we create a new list with those transformations. Okay, so they're all doubled. So this comes up so frequently, I think, that Python has an incredibly useful shorthand for it. And I'll just write it out so you can see how it works. So first of all, I'll just comment this out for now. It looks like this. Doubled numbers equals open bracket, and then I write this sort of for loop within the brackets. I'll write n times 2 for n in numbers. And this one-liner here does the exact same thing as these 4 lines of code. Now, if you don't get this or you're concerned by it, don't actually worry about it too much. I just wanted to show you what it is so that if you see it later on, it doesn't alarm you. I'll provide a link to sort of an actual in-depth tutorial about what a list comprehension is in the description of the video. And that is it for this tutorial. Please let me know if you have any questions or comments.